Hello friends, welcome to my YouTube channel Math Cracker Holy. I am Animesh Sen. In this channel, specially I upload videos related to math of class 11, 12, become BSc and higher degree. Okay. If you like this video, then please like, share and subscribe my channel. Okay. Now we are going to discuss about Poisson distribution, the mean and variance of Poisson distribution. Okay, let's start. As we know that capital P x equal to capital R, probability of capital X equal to capital R, where x be with a random variable which follows Poisson distribution and R with the number of success. Okay, is equal to e to the power minus lambda into lambda to the power r by factorial r. Okay, lambda be the parameter of Poisson distribution. Okay, now mean or expectation of Poisson distribution is equal to summation r equal to 0 to infinity r into e to the power minus lambda lambda to the power r by factorial r. Summation r is equal to 1 to infinity r into e to the power 0 to infinity e to the power minus lambda lambda to the power r by r into factorial r minus 1. Therefore, summation r equal to 1 to infinity e to the power minus lambda lambda to the power r minus 1 into lambda by factorial r minus 1 equals to lambda into summation r equals to 1 to infinity e to the power minus lambda lambda to the power r minus 1 by factorial r minus 1. Let us consider r minus 1 equals to say t. Therefore, r equal to 1 plus t. Therefore, lambda into summation t equals to 0 to infinity e to the power minus lambda into lambda to the power t by factorial t. Okay. Therefore, lambda into for t equal to 0 e to the power minus lambda lambda to the power 0 means 1 by factorial 0 plus e to the power minus lambda into lambda to the power 1 by factorial 1 e to the power minus lambda lambda square by factorial 2 and so on and up to infinity. Okay, taking e to the power minus lambda from this as common from this e to the power lambda into e to the power minus lambda into 1 plus 1 by factorial 1 lambda by factorial 1 plus lambda square by factorial 2 and up to infinity is equal to lambda into e to the power minus lambda into e to the power lambda. As we know that e to the power x equal to 1 plus x by factorial 1 x square by factorial 2 and up to infinity. Lambda into e to the power 0, that means only lambda. Therefore, mean of the Poisson distribution is only lambda, which is the parameter of Poisson distribution. Okay. Now we have to find the value of ex square, which is equal to summation r equal to 0 to infinity r square into e to the power minus lambda into lambda to the power r by factorial r. Similarly, summation r equal to 1 to infinity r into e to the power minus lambda lambda to the power r by factorial r minus 1. Okay. E to the power minus lambda into lambda. Summation r equal to 1 to infinity r into lambda to the power r minus 1 by factorial r minus 1. R minus 1 equal to t. Therefore, lambda into e to the power minus lambda into summation t equals to 0 to infinity r is equal to 1 plus t. 1 plus t into lambda to the power t by factorial t. Okay. Lambda into e to the power minus lambda. Putting this value into this one. Summation t equals to 0 to infinity lambda to the power t by factorial t plus summation t equals to 0 to infinity t into lambda to the power t by factorial t. Okay. Summation t equals to 0 to infinity lambda to the power t by factorial t is equal to, for 0 lambda to the power 0 means 1 factorial 0 means 1. For t equal to 1 lambda by factorial 1. For t equal to 2 lambda square by factorial 2, which is equal to e to the power lambda. And summation t equals to 0 to infinity t into lambda to the power t by factorial t. T equal to 1 to infinity lambda to the power t minus 1 by factorial t minus 1. Factorial t means t into factorial t minus 1. T by t. After cancellation we get the result lambda into summation t equal to 1 to infinity lambda to the t minus 1 by factorial t minus 1. Let us consider t minus 1 equal to small r. Therefore, lambda into summation small r equals to 0 to infinity lambda to the power small r by factorial small r. Using the result summation t equal to 0 to infinity lambda to the power t by factorial t, which is equal to e to the power lambda. Therefore, the value of this will be e to the power lambda also. Okay, putting these two value into this one, lambda into e to the power minus lambda, e to the power lambda plus lambda into e to the power lambda. Taking e to the power lambda as common, into e to the power 0, lambda square plus lambda. Okay, therefore variance of Poisson distribution, variance of Poisson distribution is equal to variance x is equal to ex square minus ex whole square. Ex square means lambda square plus lambda, and ex means lambda. Therefore, after cancellation of lambda square, we get finally lambda. Okay, and that of standard deviation equals to SD is equal to root under lambda. Very easy to solve. If any doubt, please comment me, and thank you for watching this video till now. Okay.